Welcome, ladies and gentlemen, to your video lesson on 7.1, all about modeling linear relationships. This lesson today is kind of, how should I put this? It's more of taking the skills that we already know and applying them to real world situations. So we're not really learning any brand new mathematical techniques today, but what we are doing is taking the skills that we have learned and we're solving real world problems. So there's going to be really only three problems we go over today. We're going to read a scenario. We're going to write an equation for the scenario. We're going to graph the scenario, and then we're going to answer questions about that related to the graph. And we're going to do that 3 times over. So without any further ado, let's just dive right in. All right, so first question here. This is kind of the warm-up. We're just going to write an equation for this, and then we're going to dive in for the next one. So a department store offers frequent buyers a card to earn rewards for purchases that they make at the store. Each transaction is worth 12 points, and customers automatically earn 25 when they sign up. So this is a very typical thing, right? So, you sign up for a card, and they're like, here's your initial offer, and every time you spend money at our store, we'll give you some points, and you can cash in those points later. Let's write a function rule for the situation. We're going to let C of t be the number of points, and t be the number of transactions. So if C of t is the number of points, that's what I want to start my equation with, right? Because I want to write an equation for the number of points I can accumulate. And so what do I get no matter what? I get 25 points right off the bat. I sign up, I get 25. And then how does that change? Well, I add to it. And how do I add to it? I add to it 12 points every transaction. So that is one version of the equation. The C of t equals 25 original points plus 12 points per transaction. Or C of t equals 12 points per transaction plus 25. Both of these are exactly the same, and you know that because you know when you add, it doesn't matter what order it happens in. Okay, so that's our equation. It'll tell us how many points we can get depending on how many transactions we do. So for the next question, it says for every 100 points, the customer receives a gift certificate. How many transactions will it take for a customer to earn the first certificate? So the question becomes here, well, what do we do with these 100 points? How do I use that in the problem to figure out how many transactions there are? Well, the answer is I want to know when my customer points, okay, is actually 100 points. And so that's the equation I'm going to start off with. I'm going to take this 100 and set it or put it in for C of t, total amount of points. And then I'm going to solve for t because t represents the amount of transactions that it'll allow me to take to get to that point of 100 points. So let's start off with that. Move this over a little bit. All right. So we want to solve this for t. Extend this a little bit. Okay. So this is a classic two-step equation. The first, what's happening to t, I'm multiplying by 12, and then I'm adding 25. Last thing I said was add 25, so we're going to subtract 25 from both sides. So minus 25, 25. That'll give me 75 is then equal to 12t. And now I got to divide by 12 on both sides. And when I divide by 12, I believe I get 6 point, so t equals 6.75. Now, we got to go a little bit further in this question because we're not going to be able to do 6.75 transactions, right? It's not possible to do a partial transaction. So what we have to do is round this up to the next one. And so we're going to say 7 transactions. Right? So in order to get 100 points, we need to make 7 transactions. All right, awesome. So that's kind of the idea of what we're doing today, except we're going to dive further in the subsequent problems here, and we're going to graph. So let's read this one together. It says, the Booster Club is selling T-shirts and blanket wraps to raise money for a trip. The band director has set a goal for the club to raise $1,000. I'm going to underline that because that's important. The Booster Club president wants to know how many T-shirts and how many blanket wraps they need to sell to meet the goal. So right now I'm kind of thinking to myself, like, okay, they need to meet a goal. What are they doing? They're selling 2 items in order to raise money to get to that $1,000 mark. So they're selling T-shirts, and T-shirts cost $10. I'm going to underline that. And the blanket wraps cost $25 each. So I'm going to underline that information because that's important. us is to write a linear equation that describes the situation, and we have to define our variables, which means we're going to put variables into our function. And because it's a real world situation, those variables actually represent real things. And so we have to identify what those are. So my linear equations, let's go back to the problem. What's my goal? My goal is to get $1,000, right? So I'm just going to start with $1,000 as my goal, and I'm doing some stuff to get to that. What am I doing? I'm adding up my sales, okay? So maybe we can do this. We can say like goal would then be equal to total sales, right? And now we can kind of separate our thoughts into that. What's the goal, right? $1,000. And how am I getting my total sales? Well, I'm selling t-shirts. $10 per t-shirt could look like 10 times T, right? And then I'm adding to my sales by also selling wraps. And so I can say that, and those are $25 a piece. So every wrap I sell is $25 per wrap, and so we'll use W for wraps. You can use X or Y. In fact, I think I'm going to go back and do that just because on my graph I have an X and Y axis, and so I'm going to go change this. So 10X plus 25Y. Couple things. You could switch this around and it would not be incorrect, meaning you could have 25x plus 10y, but then realize later on, and I'll talk about this, your graph is going to look slightly different. It's not wrong, it's just going to look different. It's going to be a different representation of the same exact thing. Okay, so it said define our variable. So what does x equal? It's the number of shirts sold. And what is y? Y is the number of waters sold. Waters, wraps. I'm actually thinking of the next problem, wraps. Okay, so we got our equation. Now we're supposed to find 2 points on this line, and we're told to use the intercepts. If this wasn't there, hopefully you would think to yourself like, oh, the easiest points to find are the x and y intercept because we get to use 0 to substitute in the equation to do that, okay? So we're going to find the intercept. So remember, to find an x-intercept, to find any intercept, you use the equation and you substitute 0 into the other one, right? So if I'm finding an x-intercept, I'm substituting 0 in for y. So I'm going to do that. Finding a y-intercept, I'm going to substitute 0 in for x. So I'm going to go ahead and take that equation, 1,000 is equal to, finding an x-intercept, so 0 goes in for y, so 10x plus 25 times 0. This is something we learned last semester, so it shouldn't be too bad. Remember, the 25 times 0 goes away. 25 times 0 is nothing. So I'm left with 1,000 is equal to 10x. And now I just divide by 10. Divided by 10. And I get x is equal to 100. Now, 100 is not an x-intercept. That is a value in the coordinate point. So the coordinate point is 100, 0. Okay? Y-intercept. This over here. Y-intercept. Now I have to substitute 0 in for x. So it's going to be 1,000 is equal to 10 times 0 plus 25y. 10 times 0 goes away, so I have 1,000 is equal to 25y. Divide by 25, divide by 25, and I end up getting 40. I'm going to verify that just because 1,000 divided by 25, yep, 40. So y equals 40. And so I have the coordinate point, I substitute 0 in for x, and I got 40 for my y value. So those are my x and y intercepts. Okay. Now, we have to graph this. So remember my x-intercept was 100, 0, and my y-intercept was 0, 40. Okay? It says use the graph to find another point on the line. First, we got to graph this. So 100, 0 is right here, and 40, I'm sorry, I did that wrong. 100, 0 is right here, and 40, 0, or 0, 40 is right there. Those are my x and y intercepts. I'm going to try to draw a line as straight as possible. Not the easiest thing in the world. Okay, so here's what we need to understand about this, okay? What I just found are 2 solutions to the problem. 100 means that I could sell 100 t-shirts and no wraps and meet that goal of $1,000. I could also sell, for the y-intercept, I can sell 0 t-shirts and 40 wraps and also meet that goal. The other thing that is really, really important to understand is that every single point on this line is also a solution to that problem, okay? And so when I find another point on the line, what I'm finding is another combination of shirts and wraps that can be sold that would make my goal of $1,000, okay? So find another point on the graph. To me, it looks like 40-20 is on the graph. Now, here's the deal. When you're drawing this out by hand, you might be off by a little bit. That's okay. It should be clear to any of us what that point is on the line or not, depending on the line you drew. Now, if you draw your line like this, like don't, right? Try hard to make a good line. And so for me, it looks like the point 40, 20 is on that line. Now, what does that point mean in the context of this situation? What that means is that, and maybe I'll type this out instead so it's a little bit easier, it goes faster. It means they can sell 40 shirts and 20 wraps. And you have to say 2 things when you answer this, or 3 things rather. You have to say what X means, what Y means, and why you're doing it, okay? So they can sell 40 shirts, 20 wraps, and they will, and then they will earn $1,000, or you can say they'll meet their goal, or they'll have raised all the money they need, or something like that. You have to mention the reason why they're doing it. All right, then this next part is asking us to use the graph. So it says use the graph to approximate how many blanket wraps must be sold if they sell 75 t-shirts. Now, one thing I forgot to do here is to label the axes. So I'm going to do that. And so we said that, like, if we go back here, we said that X was the number of t-shirts sold and Y is the wraps. That essentially labels our axis for us. So the x-axis is the number of shirts. Y-axis is the number of wraps. And I'm going to do this. Now it's kind of labeled. Okay, so if I sell 75 t-shirts, how many wraps must I sell? So I'm going to go to 75. So if this is 60, that's 70. 75 looks like it's here. Okay. So I'm going to go up there on the graph, and then I'm going to go over to here on the y-axis, and that looks like about 10. So I'm going to say about 10. Now here's the thing about this, about 10 wraps. In order to get credit for this task, it says to use the graph. It does not say take 75 and substitute in the equation and solve it, okay? It says to use the graph. So I need to see this line on the graph in order to know that you actually use the graph to make an approximation, okay? That needs to be there. That's required. And so that is the first question. The next 2 are going to be similar, different scenarios. So let's dive in. All right, so sandwich shop sells sandwiches for $5 and bottles of water for $1. The owner of the shop needs to earn a total of $100 by the end of the day. So he's got a goal in mind. So this is kind of similar, right? It's almost the same situation, only I'm selling different stuff and I still have a goal in mind. And my goal is $1,000, and I'm selling sandwiches and water bottles instead of t-shirts and blankets. So here's what we got. It says write a linear equation that describes the situation to find your variables. So I've done that. So 100 is equal to 5x. That's 5 times the amount of water bottles sold, and plus 1y, and y is the number of water bottles sold. Okay, so x is sandwiches. I think I said that wrong. X is sandwiches. Y is waters. Okay, and so this would meet our goal, right? So to kind of make this similar to before, this is our goal, right? And that has to be equal to our sales, right? So how are we getting our sales? We're selling water bottles, waters, and sandwiches, and our goal is to get $100. So here's our equation. Now, I already have the workout for the x and y intercept here because it's something, again, from first semester, but I'm going to show it to you. So for the x-intercept, I'm substituting in 0 for y into that equation. So there is the y. 0 is going in for y right here. And so I'm substituting in 0. So 1 times 0 is 0. I'm left with the 5x. is equal to 100. I'm dividing both sides by 5, and I get x equals 20. But again, that's not an x-intercept. That is the x value of the coordinates, so it's 20 comma 0. And then for the y-intercept, I'm substituting 0 in for x, so 5 times 0 goes away. I'm left with just the one y. And so then y is just equal to 100, and I substituted in 0 for x, and I got 100 for my y-intercept. So my x-intercept is 20, 0. My y-intercept is 0, 100 for that, okay? And again, what that means is that I can sell 20 sandwiches and no waters to meet my goal of $100, or I can sell 0 sandwiches and 100 waters and still meet my goal. That's what that means. All right, graph the line and label the axes. So again, I transferred over the x and y intercept here, and I've already labeled my axes. So sandwiches, we said was our x value, so that's the x-axis. Waters was our y value, so that is our y-axis. And now we have to graph it. So 20 comma 0 is my x-intercept, that's here. And 0, 100 is here. Okay, now if you're making this graph on your own and you make your scales differently, like maybe you counted by 2s or 3s or whatever it might be, your graph might look different. And that's okay as long as you are accurately creating your graph. I just decided to count by really 5s here, 5, 10, 15, 20. And here I counted by 10s, 10, 20, 30, 40. And that helped me fit everything on. Okay, you might have done it different. You might have got a different result. No problem as long as it's accurate. Here's my line. I'm actually going to use the line tool here. And so there's my line. Okay. It says use the graph to find another point in the line. Same thing. So to me, it looks like the point 10 and then 50 is on that line. So I'm going to say 10 comma 50. And what does that point mean in the context of the situation? Well, that means they can sell 10 sandwiches and 50 waters to meet a goal, or to earn $100, or however you want to say that. Okay, that was my x and y value are. And the same kind of questions before. Use the graph to approximate how many sandwiches must be sold if the owner sells 75 water bottles. So 75 water bottles. Now that is a y value. It's not an x value, right? Waters are sold is right here. So if this is 60, that's 70. 75 is about there. So I'm going to go and again approximate. So if I see this line on your graph, I know you did it. And that coordinate point is 5 comma 75. And so the answer to that question is about 5 sandwiches. Okay, next problem. So local charity is selling seats to a baseball game. Seats cost $20 and snacks cost $5 additional dollars. The charity needs to raise $400 to consider this a successful event. Same type of scenario, right? So for this one, I have 400 as my goal, and that's got to be equal to, and I suppose it could be more than that, right? But it's got to be equal to 20 times the amount of seats that I sell and 5 times the number of snacks that I sell. So then 20x, if I say it's 20 times x, then, in here in the problem, it's $20 for a seat. Then x must be seats. And then for, say, 5 times y, well, y is a snack cost. So that's why we have y as the number of snacks. Again, here I have the x and y intercept worked out for you. You can pause the video and kind of check the work here. The x-intercept works out to be 20, 0. The y-intercept ends up being 0, 80. Okay, you can pause it here, kind of observe the work. Again, finding an x-intercept, 0 goes in for y. Finding a y-intercept, 0 goes in for x. And we have to graph this. So I have my axes already labeled. This one I counted by 5s again and went out to 60. This one I counted by 5s and went up all the way here. And so again, just make sure yours is accurate. I'm going to graph 20, 0 first. So 20, 0 is right there. And then 0, 80. And I'm going to get that line tool out and then graph that as accurately as I can. And now I have to use the graph to find another point on the line. And so what does it look like? It looks like another point on the line is right about there. I'm going to find a different one. I'm going to find this one here. So it looks like this point is on the line. And that point is 1520. So it looks like 1520 is on the line. Okay. What does that point mean in the context of this situation? Again, I'll type this out so it goes a little faster. That means they can sell 15 seats and 20 snacks to meet the goal, okay, or to earn their $400, okay. And then the last question again: use the graph to approximate how many snacks the charity must sell if 15 seats are sold. Well, darn it, it just so happens that I already used that one, right? So 1520 is on the line. I thought for sure, I couldn't remember. I thought for sure 1040 was going to get used. So we can, say 1040 is on the line there, right? Either one of these. And then 1520 obviously is the one that we just looked at. So we know for sure that it's about 20 seats. I'm sorry, it's 20 snacks that must be sold. Okay. And that is your lesson for today, ladies and gentlemen. So I hope this was a good lesson for you to kind of learn how to apply some of the things that we've talked about already in class. Without anything else, you guys got your independent practice here. Make sure you're doing your Schoology check and your picture uploads. Hope you have a great day. Peace.